suppose we had, oh, yes, let's classify this thing. What is this?
Second order differential.
It's a Twackelch node.
Second order.
It's not actually.
Yeah,
It's a new thing.
Wait. Before you get to non-homogeneous, what is it?
Linear.
It's linear.
Has to be in order.
Second order, well, non-homogeneous doesn't really mean much if it's not linear.
Okay.
Right? Homogeneous and non-homogeneous are about, is it a linear thing equal to 0 or a linear thing equal to some function of
It's
x?
a 12 node.
So this is a second order linear, non-homogeneous ODE.
Can you say that
Twallow?
it doesn't have
Twantode.
constant coefficients, or is that just kind of arbitrary?
Yeah, I'm not going to say that this one doesn't have constant coefficients. I'm just going to assume they're not constant unless they're specified as constant.
Okay.
So yeah, I guess you could put a non-constant in here, but
Keep adding words.
actually so I don't quite have, right, that P of x and Q of x aren't constants. You can see that they could be constant functions of x. So this classification, the non-homogeneous part, is really my assuming that f of x isn't identically 0. Isn't identically 0.
Oh, that'd be so easy.
Right. One of the things that we should probably familiarize ourselves with is this little theorem. And this doesn't actually help you solve things. It just helps you get started. So to get started, you do the same way you do with first order linear equations. You just
assume it's homogeneous.
Yeah, assume it's homogeneous, right? And then do something.
Variation of
So-
parameters strikes again.
Yeah, probably variation of parameters. We're going to do a couple other things before we get to variation of parameters here, but we're going to do them relatively fast because variation of parameters is still the right answer.
I knew it.
So,
It's never wrong.
yeah, that was the moral of the first time I taught it in this book. So, in my little theorem, I'm going to suppose that I solved. So, suppose I have two solutions, y1 and y2, that solve.
There's an O in there, Joe.
What? In suppose?
Yeah.
There's lots of letters in suppose.
Good job, Nye.
I know, but it's like one of the main sounds in the word.
Okay.
Neglecting it.
Suppose?
Yeah.
What? No, that totally says suppose. Okay, so suppose y1 and y2 solve this thing. And yp solves y double prime plus p of x. Y prime plus q of x, y equals 0. Oh, not 0, equals half.
Is that the particular?
Right, so I suspect that I'm going to be able to find some solutions to homogeneous things. So I got my two solutions to the homogeneous thing. And these really I probably need to think are linearly
Independent.
okay.
They're all sometimes.
Okay, so if I found two linearly independent solutions to the homogeneous version and a particular solution to the differential equation, then y, the general solution, is given by, guess what?
That's something with E.
It's non-constant.
Cosine.
Here. So
There is no E.
think more generally, right? You found y1 and y2. They might be e to the whatever, or they might be something totally different. Like if y1's 1 over x and y2 is x cubed, and yp is cosine. How do you add those together or something to make a general solution?
Is that the A plus B thing? No.
Yeah, kind of.
You
Yeah.
just slap the
Right?
A's.
You need some
RC
constants, right?
plus B.
So you do
You multiply those two together.
ay1, right?
And
Yeah.
then
plus by2
Plus yp.
plus yp. And yp specifically doesn't get a constant, right? So the kind of thing I'm thinking here, it's like, alright, if I plug y1 in, I know that's going to zero out. So a constant multiple of that will still zero out. If I plug y2 in, that'll zero out. And the derivative's linear, right? So if I have two things, I add them together. If I differentiate, that's the same thing as their derivatives added together. You guys with me on that?
So this is my
So-
guess.
If I plug this stuff in, all of it's going to cancel out. And yp I know solves specifically for that f that's hanging out on the end. That's cool. So, then y like this is the general solution. This is really kind of convenient in that you don't have to keep looking. Right? If you found two linearly independent solutions and a particular solution, you can just stuff them together and be done. You don't need to go looking anymore. Cool.
So you can just say that part of it's homogeneous and find those.
Yeah, you really consider the homogeneous version, right? You know there's going to be two solutions to that, so go lay your hands on them. I haven't given you a technique for that yet, right? So if you could go lay your hands on those two, then you might have another technique for this particular one. And then once you've got the three, you put them together. Cool.
It's a lot of work.
It is a lot of work.
This whole class is a lot of work.
Okay, do you guys want to try one?
Yeah.